Yes, sir. I know the sir, but V2 is equal to V3 coming, V3 is equal to 1 by 5 V1 coming. How to solve?
So three equation you got 11 V1 minus 6 V2 minus 3 V3 equals to 40. First equation. And the second equation is minus 6 V1 plus 7 V2 minus V3 equal to 30. And the third equation is minus 15 V1 minus 5 V2 plus 26 V3. Okay, equals to 0.
Yes, sir.
So you just correct the equations once again, okay, and try and send me the solution. Then only I can check, na?
Okay, sir.
Okay. So today we are starting a new technique, mesh analysis.
Sir, can you repeat those equation again? I have to check once more.
Okay. Actually, you should send me the solution first, okay? Because the equation may not be correct. Okay. So 11 V1 minus 6 V2 minus 3 V3 equal to 40.
Sir,
Okay.
is equal to 0 now, sir?
Huh?
Is equal to 0 coming, sir. 11 V1 minus 6 V2 minus 3 V3 is equal to
3 V3 40 equal to 40. Okay. And second is minus 6 V1.
LCM part को उधर को बेच तो 0 आता ना, sir.
You just check it. How can I say now if you until you don't send me a solution? 40 is there in there, okay? And the minus 6 V1 plus 7 V2 minus V3 equals to 30, and minus 15 V1 minus 5 V2 plus 26 V3 equals to 0. Okay. See, whatever answer is coming, you send me. You send me the solution. Okay. Then I will check it, which is correct. Okay. So you have to focus on concept mainly. Okay. Whether that's numerical putting values, and that is a different thing. First, you see whether you have written the equation properly or not. Okay, that is the most important thing. So let us start now. Mesh analysis. So what are the steps in mesh analysis? Okay, steps. So number one step is that you should identify the mesh. Okay, so we already discussed what is mesh. So identify the mesh and assign direction to it, Okay. Assign an unknown current to each mesh. Okay, to each mesh. Then once you have identified the mesh, you have assigned the current and direction. Then the second point, assign the polarities. Assign the polarities, okay, of voltages across each branch. Okay. So basically, this is a method is combination of your Kirchhoff voltage law. So you have to apply KVL around the loop. Okay, keeping in mind the Ohm's law. So this is a basically technique, use KVL and Ohm's law. And once you are done this one, you assign the polarities, everything, and then you have to write the KVL. Okay, apply KVL in each mesh. Apply. Once you know the polarities, now you can apply the KVL. Okay, in each mesh. Okay, and then you will get, depending on the number of meshes, if 2 meshes, you get 2 equation. So solve the simultaneous equation. Yes. Direction to it. Identify the mesh and assign direction to it. Okay. Then assign an unknown current to each mesh. And the fourth point is solve simultaneous equation. Solve simultaneous equation. Okay, so let us illustrate this technique by an example. So I'm taking a, so we can have a number depending on the loops. We can have a unknown currents. Okay, I'm taking first a simple example where we have only one unknown current. So your circuit, say plus minus 10 volt, and then we have a 4 ohm resistance, then we have a 6 ohm. Okay, this is my loop one, and the second mesh is already a current is given 5 ampere. Okay, the resistance is 3 ohm. So this the, so we have a total 2 meshes. Okay, mesh means independent loop, we already discussed. So in this circuit we have 2 meshes. Okay, let me call this is a mesh number 1 and this is mesh number 2. Okay, now the step 1 is you have to assign the direction. Okay, so with which direction you are going to move. So I'm going to move in clockwise direction. Okay, so you have to keep the direction same. That is the first thing. You cannot go clockwise in one mesh and others in counterclockwise. So that you have to be consistent. Okay, you have to keep the direction in each loop same direction. Okay, now the next thing is the number of loop you are that number of current. Okay, assigned an unknown current. So see, unknown current is here I1 and unknown current is here I2. Okay, so current ho gaya. Now you know which direction you are moving, and current always moves from higher potential to lower potential. So this you now assign the polarities of polarities across each branch. Here already polarity given. Here this will be plus, this will be minus. Okay, this will be plus, this will be minus. Similarly here I2, here this is a plus, this is a minus. Okay, this is a plus, this is a minus. So now you know all the polarities. Okay, now you want to find write the KVL. So if I write the KVL here, okay, so I can write minus 10 10. Okay, then current is here, voltage is 4 I1, resistance is 4, current is I1, and in this resistance, okay, can you tell me resistance is 6, current is how much? What is the current in this branch?
I1 minus I2.
I1 minus I2. Okay, so this is I1 is coming here, I2 is coming here. The current is I1 minus I2 equals to 0. Okay, so the equation become 4 I1. Okay, and this 6 I1, this become total 10 I1. Okay, 10 I1, and then you have minus 6 I2, and this you have 10. So this become 5 I1 minus 3 I2 equals to 5. Okay, this is the equation number 1. And another loop. Okay, I have assigned the current I2, but there is already current source here. So the current is fixed here. So current, what is the value of current here? In second loop, what is the value of current?
5 amperes.
5 minus 5. Okay, because you assign I2 here, current is like this. So I2 is minus 5 ampere. Okay, now put this value here, you can find I1, I2. Okay, so 5 I1 minus 3, so minus plus, this become 15 I2, 15 total 15. Okay, values plus 15 equals to 5. So 5 I1. Okay, so this become minus 10, and I1 is your minus 2 ampere. Okay, so I2 is minus 5 and I1 is minus 2. Okay, that means we have assigned here, and exactly the current is opposite. This 5 ampere current is going here. Okay, out of this 5 out of this 5, 2 is going here and 3 is coming here. Okay, so what will happen if 2 is coming here? This is 10 volt, and how much is going here? 2 is going here, so 10 volt. Okay, this is 8 volt. Opposite. This will be opposite, and then remaining voltage will be here. You can apply the KVL and check whether it is correct or not. So we have current value I1 minus 2, I2 is also minus 5. Okay, so can you check here? Can you apply KVL here? What is the voltage here? Tell me now. Tell me. So 5 is going here. Okay, 2 is going here. So plus minus. So please check it voltages also. So this is a simple question where only one current is unknown. So we have to write only one equation. Other current is known. Okay. Now let me write
minus 18 volt.
हाँ पूरा चेक करके बताओ वो फिट बैठ रहा है कि नहीं बैठ रहा है. माइनस नहीं तो अब तो पोलैरिटी चेंज हो जाएगी. अगर आप करंट पता चल गया अब तो पोलैरिटीज भी चेंज हो जाएगी ना.
सर बीच में से लेने तक कौन सा मेश कंसीडर करने का?
क्या चीज?
बीच में जो 6 ओम था ना उसके अक्रॉस हमें वोल्टेज अगर निकालना है तो लूप की डायरेक्शन कौन से कंसीडर?
अब तो करंट मिल गया. अब तो लूप तो वही है. अब तो करंट मिल ही गया ना आपको. अब तो पता चल ही गया करंट कितना I1 माइनस I2 है ना उसके अंदर. I1 का वैल्यू पता है, I2 वैल्यू पता है, तो कितना आ जाएगा बताओ?
प्लस 18 वोल्ट. चेक कीजिए सर.
प्लस 18 वोल्ट जो भी आ रहा है. प्लस 18 यहाँ पे 10 इधर है, 8 उधर आ गया. That will be correct. You can check. Okay, let me give you one more problem. वो तुम अपने आप चेक करना उसको बैठ के कि ठीक है, तभी तुमको क्लियरिटी आएगी. Now you have 15 volt and you have a plus minus 10 volt, and then you have 4 ohm, 6 ohm, 5 ohm, 10 ohm. Okay, so let us solve this problem. So we have two meshes. Okay, I am assigning the current like this. Say this is I1, this is current I2. Now that be what should I write? So first, in the first mesh I will be minus 15. Okay, so here I1 current is moving, so plus 5 I1. Okay, here again current is coming I1 minus I2, so 10
into I1
minus I2, and then you have a plus 10 volt also here, plus 10 volt. This is the loop 1. Okay, so 5 I1, 10 and 15 I1. Okay, and then minus 10 I2, and then here minus 5 will be remaining, so 5 can come here. So 3 I1 minus 2 I2 1. Okay, so this is the equation number 1. Okay, now if you see the second loop, now here you carefully see the second loop. I already assigned the polarity here. Polarity assigned already. I already assigned the polarity. Okay, this. Okay, now here I was starting here. So first is minus 10, then minus how much? Minus 10. What is the current here? I1 minus I2. I1 minus I2. Then here current is plus. Current is what? 6 I2. And here final, here current is 4 I2. So that is equals to 0. Okay. Now here instead of I1 minus I2, you can also write I2 minus I1 also. But if I2 is more, then this polarity will come plus, this minus. So the thing is same. If you put it I2 minus I1, then this should be plus, because then if the sign I2 current is more, then this will be plus, this will be minus. So once I have assigned this one, so I am keeping like this only. Okay, you can do other way also. Clear?
मेश की डायरेक्शन से भी लिख सकते हैं ना हम?
हाँ,
मतलब मेश में जो करंट का डायरेक्शन है उसके इससे भी लिख सकते हैं ना?
तो उसी तो लिखा है नहीं, इसमें करंट कितना है, I1 minus I2 है. Current either is I1 minus I2 या I2 minus I1, which is more. Okay, so I'm assuming I1 minus I2. So this drop plus minus. Now if you want to, once this over, now second time you are moving in this direction, you say I'm moving I2 direction, I want to plus here plus, because I2 is moving here, so you want to make it plus, then you make plus, it plus, then minus, then current will be now I2 minus I1. Okay, but since we have fixed this one polarity, so I'm keeping current like this only. If you want, you can make I2 minus I1 also, but then this will be plus. So the thing is same.
How can we fix the polarity, sir?
See, you are saying current moving in this direction. So this is plus, this is minus. Now you saying here the net current is moving like this. Current I is more than I2. Net current is moving like this. So this will be higher point. This will be lower potential, and this is plus already writing. Now here you saying current moving like this. So current moving, this is higher potential, lower potential, higher potential, lower potential. Okay, this is already given fixed. Now here, because I1 is greater than I2, that you can put I2 minus I1 also. If you want to write I2 minus I1, then you have to put plus here, minus 1 here. Clear?
No question. Yes, sir. Yes, sir.
Okay, वो दोनों same चीज है ना, तो both are same चीज ना. If you write I2 minus I1, then this will be plus, this will be minus. Okay, so the thing is same. Now what method you adopt, that is your choice. Okay, now let us solve this one. How much is coming? So
I1 I2
so 10 I1 plus 10 I2 plus 16 I2
minus 2 I1 minus 1.
huh?
I2 minus 2 I1 minus 1.
दोनों 1 1 आएगा. See what I'm getting here, minus 10 I1, okay, minus plus 10 I2, 16 I2, 20 I2 plus 20 I2, that is equals to 10. So I am minus I1 plus 2 I2 equals to 1. Okay, now you have to solve this equation. The equation is correct, then it's give I1 1, I2 1. I1 equals to 1 ampere, I2 equals to 1 ampere. Okay. So are you getting this one, Shivani?
Yes, sir. Coming, sir.
Okay.
Sir, I have a doubt, sir.
Ask. Ask.
We write 10 into I1 minus I2, na, sir. Then how we write I1 minus I2, sir? I can't understand that one.
So here, this is your branch. Okay. One current is coming, I1 here. Yes or no?
Yes, sir.
Second branch, same branch, I2 is coming here. Yes or no?
Yes, sir.
So what is the current here? I1 minus I2.
Okay.
Okay.
Okay, sir.
You can make I2 minus I1 also. There's something again. You can, this is plus, this is minus. If you want to say no, current is I2 minus I1, write it I2 minus I1. Then this polarity will be plus and this will be minus. Both the same thing.
Got it, sir.
Now, give me one problem from exam. Okay. So in GATE 2008, okay, they asked two ampere, 5 ohm, 10 ohm, okay, and then you have your I2 is 15 ohm, okay, and here again you have a 20 ohm, plus minus 20 volt. Okay. So in this question, okay, they're asking write the loop equation. Okay. So they have given some equation. You have to find out the correct equation, which is correct for any of the one loop. Okay. So you have equation 30I1 minus 15I2 equals to 10. Options are given. So which current equation is correct for one of this loop? So minus 15I1 plus 20I2 equals to 0. And option C is 30I1 minus 15I2 equals to minus 10. Okay. And the D option is minus 15I1. Okay. Plus 20I2, then 20. Okay. So out of this four equation, which equation is correct? For
कौन सा है करेक्ट?
ये तो तुम बताओगी ना. I1 I2 इसमें दे रखा होगा ना. इसमें फर्स्ट लूप में I1 ये दे रखा है, या I1 है या I2 है, आप बताओ. निकालो कौन सा सही है. Which equation is correct? Out of these four equations. So you have to follow the method. You have to assign the current in each loop. So here you have assigned I1, here I2. Here no need to assign, because in this loop you can assume the current is 2 ampere because fixed source is given. Now I'm giving you 2 minutes. Solve and tell me what is coming. Okay, so let us solve this problem.
Is it option A?
Option A is correct. Yes, option A is correct. Okay, option A is correct. So let me remove other options and write the equation in loop 1. Okay, so in loop 2 I'm writing the equation. 1 is already known. So here current is what? Current is how much here? 2 here, and I1 is current. I1 is coming here. Yes or no? I1, this is 2 is coming here, and I1 is from here. So current is, so resistance is far. Okay, so I am moving like this. Okay, so this will be plus, this will be minus. So sorry, I'm moving here. So this is plus, this is minus. First you have to assign the polarities. So I'm assigning the polarities like this. This is plus, this is minus, this is plus, this is minus, this is plus, this is minus, this is plus, this is minus. Okay, depending on the current. Okay, I'm assuming 2 is higher. So the polarity is plus minus. Now I'm moving like this opposite. So I'll get minus here. Okay, minus, I get 5, then I get 2 minus I1. Okay, then I write here 10 I1. Okay, then I come here again, I write here 5 I plus current is I1 here, I2 coming here. So 5 I1 minus I2 equals to 0. Okay, so this become minus 10 plus 5 I1 and 10 this I1, 15 I1, and this one coming. So how much will come? Just 1 minute. Is there any mistake? 2. So minus 5, 10. This is plus 5 I1. Okay, and this is 10 I1, and this is 5 I1, 15 I1. This is 15. This is
15 I1.
Ah, this is 15 I1, correct. And minus 15 I2 equals to 0. So 5, 10, 30 I1. Okay, minus 15 I2, and there is a 10 equals to 10. Okay, so the option A is correct. किसी ने क्वेश्चन भेजा था मुझे व्हाट्सएप पे. ओके,
Yes, sir. I am only, sir.
ओके, So this is your correct answer. Now, let me solve one more problem.
Sir,
Hmm.
why we take here 2 minus I1 minus 5 into 2 minus I1?
What you want to take? According to 2, what should be?
Minus 5 we already have taken.
Okay, this is current is there. 2 is coming here. Okay. I1 is coming here. So what is the net current here? What is the net current
2
here?
minus I1.
2 and I1. Resistance is 5 ohm. Okay. Now so you write plus here, minus here. Okay. Clear? Now I am applying
Okay, sir.
KVL here, na? So I will get minus first here, na?
Yes, sir.
Whatever polarity will come here, that's why I'm telling that it's important to put polarities first. You decide first. That is your choice. Nobody is saying you. So you only you have to mention the direction of current. If current is moving here, and this will be plus, this is minus. Here you are uncertain whether it's a plus or plus or minus. That is your choice. You decide which current is higher.
So, but in last question, when we have taken this minus polarity, then we have taken I2 minus I1.
लास्ट क्वेश्चन में यहाँ पे माइनस लिया था तब.
Yes.
हाँ तो I1 माइनस I2 लिया था ना. तो अभी भी तो I1 माइनस I2 ले रहा हूँ. अभी कौन सा ले रहा हूँ? अभी ये I2 थोड़ी है, अभी I1 है ना. पहले ये I1 था, अभी ये I1 है आपका.
नहीं सर, अब ओके ठीक है.
अरे वो I1 I2 वो ये वहां पे सेकंड लूप ये था ना.
ठीक है सर, ठीक है.
हाँ, ऐसा याद थोड़ी करोगे.
नहीं सर, वो मुझे लगा कि आपने.
Okay. So now this CSIR net, okay, June 2020 question. Okay, so you have been given a 100 ohm resistance. 100 ohm resistance. Okay. Then you have been given here a 150 ohm resistance. Okay, this is 20 volt battery. And here you have a 100 ohm resistance. 100 ohm resistance. Here you have 200 ohm resistance. Okay. Now you want to measure the voltage across this resistance. Okay. So in question में क्या दे रखा है that you are measuring the voltage across this 100 ohm. Okay, using 2 voltmeters. You have 2 voltmeters. Okay, so you are measuring the resistance using voltmeters. When you have a voltmeter 1, okay, voltmeter 1, okay, V1 voltmeter has the resistance equals to internal resistance equal to 2 mega ohm. Okay, so it is given RI, internal resistance of this voltmeter is 2 mega ohm. Okay, in first case. And second case for V2 voltmeter, okay, internal resistance is given equals to 0.1 kilo ohm, 0.1 kilo ohm, that is equals to 100 ohm. Okay, now he's saying measure the voltage here. Okay, and the ratio of V1 upon V2. Okay, find the ratio of V1 V2. Okay, you don't need to find the ratio of V1 V2. So calculate the ratio of V1 V2. What is the voltage here? And when you have voltmeter V1 here, and when second case when the voltmeter is V2, what is the voltage here? Question is clear or not? Okay, now when you put voltmeter V1 here, okay, so voltmeter has an internal resistance. Okay, voltmeter has an internal resistance of 2 mega ohm. So this will be your 2 mega ohm. Okay, first case. So if I take equivalent resistance of these two resistances, so how much will come? 1 plus 100 plus 1 by equivalent of this one, okay? 1 by R equivalent of these two resistance. It will come 1 upon 10 raised to power 6. So what is the value of R equivalent? Tell me. What is the value of R equivalent in the first case? I'm taking, this is the equivalent of these two. What is the value of R equivalent? It will be approximately equal to what?
2 mega ohm.
कितना आएगा? See, 1 by 100 and 1 by 10 raised to power 6.
100, approximately 100.
Yes, that's what I'm trying to say. So when you have a high resistance voltmeter, it will not affect the resistance of the circuit. That's the point. So that's why we always use a voltmeter in the circuit which is a high internal resistance. So if you put the voltmeter now here, it will give you the accurate voltage here. It will not consume any current because this is not affecting the resistance of this. So ultimately it is not affecting the resistance of the circuit. Okay, so this is the ideal voltmeter. Okay, so now if I take the equivalent of this one, this will come almost 100 ohm. Okay, so resistance is not affecting. You can neglect this one. Okay, so resistance is only 100 ohm. Now you find the voltage across this one. Find the V1 here. Now in order to find V1 here, you need current here. Okay, so let us say total current is coming here, I. So first find the total current. What is total current? Total current is equal to total voltage equal to total resistance. Okay, total resistance. So total current will be what? So first you find the total resistance of the circuit, RT. What is total RT? Okay, so RT will be 100 ohm plus current will come here, divide here. These both are series, and then this resistance 150 and this 2 and 300 they are parallel. Okay, so 150 is parallel to 300. ये point, is this expression clear? Parampreet.
Yes, sir, clear.
ये 150 है. See, this is a 150 and this 300 is parallel to 150. Okay, so I'll take equivalent to this one, and then finally I'm adding this series resistance. So this 100 plus 150 into 300 upon this total sum कितना जाएगा? 450.
1 by 10 आ रहा है क्या?
So this will be 1, this is 3. Okay, and this 3, this will give you 100. So 100, resistance coming 200. Okay, so resistance is 200. Now you want to find the current I total. So the voltage is 20 and this is your 200. So 1, so 1 by 10. So your current is 1 by 10 ampere. I total current is 1 by 10 ampere. Okay.
Sir, in 1 by R equivalent, 1 by 100 plus 1 by 1 into 10 power 6, na sir?
This is how much? 300. Okay.
Yes, sir.
Then 150 plus 1 upon 300, how much will come?
Not that one, sir.
Which one?
1 by R equivalent. Upside, sir.
ये वाला?
Yes, sir.
How much will come? This is negligible. This is negligible, na, compared to this one. This will come 10 raised to power 0.01, and this will come how much? 10 raised to power -6. So this is negligible, na?
Yes.
So 1 by R equivalent is 0.01. So R equivalent is 100. Okay.
Okay. How we write 1 by 1 into 10 power 6, sir?
So here 1 mega ohm resistance, na? 10 raised to power 6 ohm. Mega ohm resistance is what?
1. Okay.
Okay.
Yes, sir.
So now I have calculated the total current. Okay. Now this total current will now come here. This will divide in 2 branches here and this total branch. Now your 2 branches. Say this is I1 or say I2 and say this is I1. Okay. I1. So tell me what is the value of I1 now? Tell me what is the value of I1? What is the formula for I1? What is the formula for I1? Current division.
I total.
I total.
I total, very good. I total, okay, into
Opposite.
opposite resistance,
resistance.
150 divided by
Total
Three.
resistance.
some resistance.
Sum of
So,
resistance.
so how much is sum of resistance?
450.
450, very good. 450, very good. Okay. The current is 1/10 ampere. This is 150, 450. So 3, this is 1/30 ampere. I1. Now tell me what is V1. So V1 कितना आ जाएगा? What is V1? Tell me. How much is V1?
That I1 upon I1 to R1.
So I1 into resistance 100.
Yes.
Okay. So that is your 10/3 volt. So the voltmeter 1 is giving you value 10/3 volt. Okay. Voltmeter 1 is giving you value. So here is a voltmeter which is measuring. Okay. And its resistance is not affecting this one. Okay. So it is giving you the value V1 equals to 10 power 3 volt. Okay. Now let us do second calculation. In second case, you have a voltmeter V2. Okay. Voltmeter V2, which has a resistance of 100 ohm. Now this resistance is comparable. So it will change the circuit resistance. So 100 ohm, what will come? What is the value of, if it is 100 ohm and the parallel is also 100 ohm?
50, sir.
So effective is 50.
50.
So now this resistance has changed. So you have resistance now 50 ohm. Okay. So this resistance is now 50 ohm. Okay. Again, do the calculations. Now say this time the current is IT dash. Okay. And say this is I2 dash, this is I1 dash. So find first IT dash, then find I1 dash, and then tell the what is the voltage V2 here. But this time this voltage is V2.
Sir, answer 5.33 आ रहा.
हाँ? आंसर कितना आएगा?
Answer 5.33.
5.33 नहीं आएगा बेटा. आंसर तो आएगा आपके पास में 1.7 आएगा. V1 by V2 1.7. 1.7. Okay. Now let us calculate for first case. Let us do second case calculation. So second case again, the first job is to find the R total. Say RT dash 100 ohm is there, 150 is there, and this 150 is now parallel to 250. Okay, so 100 plus 100, 150 into 250 upon 400, 1, 1, 1, 1. Okay, so this comes 100 plus this comes 375 upon 4. So this comes 775 upon 4 ohm. Okay, yes or no? Check it. Is that correct? Okay, now I want total current IT dash. IT dash will be your total voltage V upon total resistance 775 into 4. So I got 80 upon 775. Okay, so this will be 16 upon 155 ampere. Okay, so 125 to 5. So this is my total current. Now once you want total current, you can write I1 dash. I1 dash is again the resistance opposite. Total current is this one, 155. The opposite resistance 150. Total resistance 400. Okay. Now we can solve this one to say how much current is coming. So this is 0, 0 cancel. This is 5. This is 5, 3. This is 3, 31. Okay. This is 4 and this is 10. So how much is coming? Just check it. What is coming? Tell me. Current value is what?
12 by 310.
12 by 310. 0, 0 cancel. 3, 8. Okay, 8, and then this is 3, 3, 5, 5, and 150. Check it. Is it so? Now this is 2, this is 5. Okay, so 2 upon again 155. Okay.
The 6 upon.
So 3 also there, sir.
6 upon. Okay, 6 upon 155 is your current. Okay, now find the voltage V2. Now for voltage V2 dash will be current is this much, 155 into 50 ohm. Okay, so this is again 5. कितना आएगा बताओ? 5, 10, 31, 60 upon 31. Okay.
Yes, sir.
Volts. Now you find V1 by V2. So if you find V1 by V2, that is 10 upon 3 and 31 upon 60,
31 by 18.
31 by 18, and that is 1.7 ratio. Okay. 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 So let us start now theorems. Okay. So technique we have learned, mesh analysis and that one. Okay. And now we have learned the theorems. Okay. So first is your superposition theorem. Okay. So superposition theorems, okay, is a very efficient technique when you have a more than one source present in the circuit. Okay. So you have a more than 2 voltage source or 1 voltage source, 1 current source. So if many sources are present and then if you want to find the voltage across any branch, then this theorem says the voltage across any branch is algebraic sum of the voltages across due to each source, keeping other source deactivated. Okay, so what is the statement? First write the statement, then we'll understand. The superposition principle state that the voltage across, okay, the voltages across, okay, or current okay, current through any element in linear circuit, okay, any element in linear circuit. This term is important here, linear circuit. Okay, the voltage across any element in linear circuit, okay, or current, okay, any element is algebraic sum, okay, is algebraic sum of voltages across or current through that element due to each independent source, okay, alone, each independent source alone. Okay, so here in this statement you have to understand that this theorem only applicable for linear circuit. Okay, you can apply this superposition principle only to linear circuit. Now, what is linear circuit? Okay, linear circuit has an element, all the branches have a linear component, that is either R is present, R, or C is present, or your inductor is present. If these three elements are present only, then the circuit is called your linear circuit. Okay, because R is linear element, the resistance value R doesn't change with the current and voltage in the circuit. Similarly, C is also linear element, the value of C, capacitance, doesn't change with the circuit parameters, and L also doesn't change with the circuit parameters. Okay, but if in the circuit there is a diode which has a variable resistance, okay, if there is a diode, if there is a transistor in the circuit, okay, and if there is a variable capacitor or a inductor L, which is a variable, okay, or a inductor which is possessed inside a iron core, then this L value will not be fixed. Similarly, the C value, if C is variable, then C value will not be fixed. Okay, these are all non-linear devices, non-linear component. So superposition principle you can apply when you have only linear element R, C, L. Okay, these are linear. These all are non-linear elements. Okay, and these are your linear element. So your element should be linear. Then only you can apply superposition principle. Okay, now technique is what? And the other thing is I'm using here independent source word. Okay, so independent source ka matlab hai you have voltage, either voltage or current source present. Okay, these are all independent sources. That means their voltages are fixed, or current it will give you fixed regardless what is the circuit. So that's like an independent source. Okay, you should not use this theorem you can use, but that was slightly you have to change. Okay, so I'm here only considering independent sources. Independent sources which give you fixed value of voltage and current in the circuit called independent source. Tell me any question?
सर एक बार अपनी मतलब मेरा रेंज चली गई थी लीनियर एलिमेंट्स का क्या बोला था करंट चेंज
लीनियर वैल्यू क्या है जिनकी वैल्यू सर्किट में करंट के साथ में चेंज नहीं होती करंट या वोल्टेज लगा दोगे इसमें कुछ भी सर्किट में इनकी वैल्यू चेंज नहीं होती है आर हमेशा आर रहेगा सी हमेशा सी रहेगा एल हमेशा इंडक्टेंस एल देगा कैपेसिटेंस हमेशा सी है दे आर नॉट वेरिएबल ओके अब डायोड का रेजिस्टेंस वेरिएबल डायोड एक नॉन लीनियर डिवाइस है इफ यू सी द रेजिस्टेंस ऑफ डायोड दैट इज लाइक दिस वन IV curve is like this it is not a straight line it's a slightly variation so each voltage current is changing current is not proportional so resistance is changing so diode is a non-linear device transistor also non-linear device these variable capacitor and the inductance variable inductors make iron core hai this all become non-linear so that should not be present in the circuit okay now the next thing is how to apply this theorem okay so while calculating the effect of one source while calculating the effect of one source जिसका हम निकाल रहे हैं one so at a time we'll take one source only so while calculating the effect of one source other sources will be deactivated other sources will be deactivated okay now what do you mean by deactivated का मतलब है if there is a voltage source okay make it short इसको शॉर्ट कर दो if there is a current source extra current source make it open ये कोई वोल्टेज देना नहीं चाहिए इसलिए इसको हमने जीरो कर दिया शॉर्ट कर दो करंट सोर्स कोई करंट देना नहीं चाहिए करंट सोर्स को ओपन कर दिया तो उससे कोई करंट आएगा नहीं so it's like when you calculate the force on one charge test charge and the surrounding there many charges are there so when you calculate the force due to q1 on the test charge then you neglect the q2 q3 q4 when you calculate the force due to q2 you neglect the force due to other charges so this is superposition principle at a time you will take one source and other sources will be deactivated now deactivation meaning you should understand that voltage source will be short circuited current source will be open circuited okay so let us solve now the superposition principle with example so this is a very useful technique okay बहुत काम आएगी आगे when you solve op-amp problems okay so I'm giving you question okay we need to solve this one with superposition principle so we have 6 volt we have a 8 ohm resistance we have 4 ohm resistance we have 3 ampere resistance okay now we need to find the voltage across this one now in this circuit mein how many sources we have
2 sources one voltage source and
one current so very good okay so now I want to find the voltage here because of these 2 sources okay so now I will so now this V will be equals to V1 plus V2 okay so V1 I will take due to 6 volts so V1 is voltage okay due to 6-volt battery, 2 to 6-volt battery. Okay, and V2 I will take, now there will be algebraic sum. V1 is due to this one and V2 is due to this one. Total is voltage V, and V2 is voltage due to 3 ampere current source. Okay, 3 ampere source, current source. Okay, now let us first calculate V1. Okay, so first calculate V1. Okay, so V1 is due to this one. So other source should be deactivated. So if the current source, you would make it open, and if it's a voltage source, you would make it short. So the current source, let it make open. So this become open. Now I want to find what is, so now only this, because due to this will be V1. Okay, now find V1. Now current will come here. This is open, so there will be no current in open circuit. So this current will come here and this current go here. So total current the circuit will be how much?
V1 equal to 2.
So 6 volt upon this is a 14 total resistance, and multiply
14 not, sir. This is 12.
12. This is 12
Into
12.
2.
12
Into
6
sorry,
by
into
12.
6.
1
into
by
4.
2. So voltage V1 will be your current 1 by 2 into 4. Okay, that will come 2 volt. Okay, so this is a V1. Now I want to calculate V2. Calculate V2. Okay, so now I'll put current source again here. That is, current source is 3 ampere. Okay, and this you make it short. This make it short. Okay, and now this time whatever voltage will come across this one, that will be your V2. Okay, this will be your V2. So now 3 ampere current is coming from here. Okay, tell me what is V2? What is the current in the V2 in 3 ohm?
2 ampere.
2 ampere. Okay, so you want to find the current here. You have 2 branches. So current in, let us say current is I2. This is I2, say this is I1. So I2 will be total current. Total current is 3. Sum of resistance in 8. Sum of resistance 12. So this becomes 4. Okay, this 2. So current is 2 ampere, and now this V2 will be 2 into 4 ohm resistance, 8 volt resistance, 8 volt. Okay, and the sum of resistance V will be what? 2 plus 8. Total your V will be 10 volt. Okay. Now same question you can do is using nodal analysis. You want this voltage. Okay, you say this voltage is V, and do nodal analysis. You can solve that same thing. Okay, so whatever method you find comfortable, but I will suggest you learn both the methods, nodal analysis and superposition principle, because that will help you a lot while dealing the circuits. Equally, both techniques are equally important.
Sir, you said na that you would get some short videos or problem set kind of thing.
I'll send. Okay.
Okay, sir.
I'll send. I'll give you a book also for practice. Okay, and I'll send some that's one also. Okay, so now let me give you one more problem. Okay, so how much time is left? Half an hour is there, no? So we can do 2 problem more. Okay, so I'm giving you homework. Okay, one thing homework, you find that one, that is your homework. Okay, so this is your 6 volt.
Sir, this previous problem we can do with another tip.
Any method you can do it. You can recheck whether other method, mesh analysis, nodal analysis, any method you can use, or you can directly, if you can solve directly, you can solve directly also with basic clause also. Okay. So this is a 5 ampere. Okay. So find the voltage. Okay, let's do it quickly. Find the voltage across this one using superposition principle. Find V. Tell me. I'm not solving. You solve and tell me how much is coming. It is the same question. It's the same question. Okay. I didn't change the question. 1 minute.
Sir, same question.
The same question. So you have this 40 volt here. So you have this plus minus 40 volt. Okay. And let me put here current source. Current source here of 8 ampere. Okay. See, this is 3 ohm. Okay. And this is 2 ohm. Okay. This is 2 ohm. Okay. Find the voltage here. Find the voltage across 2 ohm. Calculate using superposition principle. How much is coming? So first you want to find due to this one. So say V0 is equals to V1 plus V2. Okay. First only one source present, other make open.
32 volt.
No. Now first calculate V1. What is V1? Current will going here 3 to 5. So current will be 5 ohm. Circuit current is I equals to 40 divided by 5, that is 8 ampere. Okay. So voltage V1 will be 8 into 2. 32 is coming. Maybe 16 volts. Okay. So 16 volt. Okay. Sorry. 3 and 2, 5. Here any resistance was there, or here any resistance was there or not? Here.
No, sir.
Volt is not there.
Okay. Then it is okay. So then it is okay. So then 16 volt. Okay. And now you want V2. Okay. V2. Remove this one, short circuit this one. You have current only 8 ampere current source. 8 ampere current source. This is short circuit. Now this is a problem, na? So if you make short circuit this one, so what will become? If you make short circuit, so better to put one resistance here. Okay, just change this question here, otherwise it will be problem. Short circuit you can make. This is a 5 ohm resistance here. Okay, now find out. This is 40 volts. Now solve the circuit again.
So if it is as before, what will be the issue?
Then current will not go here. Huh? All current will come back here.
Yes, yes.
It will be short circuit. So this circuit becomes short circuit. This whole becomes short circuit.
Then sir, V1 becomes 8 volt and the 8 ohm current will be divided. So multiplied it with the 2.
Yes.
So it will be 2. So 8 plus 8 16 volt.
Yes, 8 plus 8, 16 ohm. Yes. Okay. Very good. So V1 will be same like now resistance current will be your, this will be open. Okay, this will be open. So 5, this 8, 10. So current will be 4 and voltage V1 will be your 8 volts. Okay. So V1 will be your 2 into how much? 4. 8 volt. Okay. And V2 will be, this time it will be short circuited. So current will divide in these two branches. Okay. So if I want to find the current in this branch, so I put a resistance this one, total current is 8, resistance of this branch, sum of resistance 5, 5, 10. Okay, this will become current and multiply by 2. This will become voltage. Okay, so this is 1, 2, 2. Again, this will come also 18 volt. So you get your V naught equals to 16 volt. Okay. किसी को doubt है क्या? I think easy question, you can do it.
Solving.
Soham, Sian, Mardul.
Clear है
सर V1 में रेजिस्टेंस वैल्यू का 4 लो
हाँ
V1 में सर
V1 में resistance is 10 ना, resistance is 10. If V1 is there, resistance is 10, 5, it is open, 5, 10 resistance, current will be 4 ampere and 4 into 2 will be 8 ampere, 8 volt. Okay.
Yes sir.
And second case, this is short. Now current will divide here and here. First you find the current here. The current here will be this will be 8 into 5 by 10. Current here and multiply by this 2, it give you V2. Clear, Bulela?
Yes sir.
सेकंड केस का जरा बताइए अभी जो बताया
सेकंड केस में करंट डिवीजन कैसा होगा? टोटल करंट 8 है. यहाँ पे कितनी जाएगी? 5 आधी जाएगी ना. यही 5 है, यही 5 है. Both resistance are 5, 5.
Yes.
So 4 will come here, 4. So 4 ampere current will come here. 4 into 2, 8.
Okay.
Okay. Okay, one homework. So you have plus minus 8 volt. Okay. So this is the 8 ohm resistance. Now you need to find current I. Find current I. Okay, total current I. So you have to keep the direction in the mind. Okay. So you have source. The source is 2 ampere. So now you have 3 sources, 8, 6, and 2 ampere. Because of this all sources, okay, you have to calculate in current in 8 ohm resistance. Find current I in 8 ohm resistor. Okay, you have to find a current in, and you have to send me the solution. Okay. So how much time is left? Okay, so we have still 20 minutes now. So I'm rubbing this one. Okay, so we're starting new. One is called Thevenin's theorem. Thevenin's theorem. Okay, so Thevenin theorem says, okay, any linear two-terminal circuit, okay, any linear two-terminal network or circuit, okay, can be replaced. Oh, better to write circuit. Networks two-terminal circuit, okay, which has a load resistance RL connected to here, okay, and now I can replace this circuit, this two-terminal network circuit, by a voltage source. Okay, I can replace this by a voltage source which has a resistance in series called R Thevenin, and this RL is again equivalent. RL have same, and this is okay. So this, the statement is, okay, a linear, right? A linear two-terminal, circuit can be replaced. Circuit can be replaced by an equivalent circuit, by an equivalent circuit, okay, by an equivalent circuit consisting of okay, a voltage source, consisting of a voltage source V Thevenin in series with a resistance R Thevenin. Okay. Now, what does this theorem says? That you have a network is given. Okay. So that network can be, say, a complicated circuit. This complicated circuit, this whole circuit can be replaced by just a voltage source and a resistance R Thevenin. You can replace this whole. So the idea is you want to get some voltage here. Okay. So you need some current here. Now, if I replace this complicated circuit just by this voltage and resistance, and if I'm getting same current here and same voltage here, so that doesn't matter what is the circuit for me. Okay. So load, if load sees this resistance, if load finds that this circuit is giving it same current and same voltage, so load cannot differentiate whether the circuit is like this complicated or this is a simple circuit. If the same circuit is giving same current and same voltage here, then for those circuits are equivalent for this resistance RL. That is the statement of this one. Okay. So once you find this simple circuit, calculation becomes very easy. So let us solve this. Now let us find how to solve this type of questions. So I want to find now V Thevenin. Okay. So how can I find V Thevenin here? Okay. So let us, both these circuits are equivalent. So find V Thevenin. Find V Thevenin. Okay. So how can I find V Thevenin? I have a complicated circuit. Okay. I have this circuit of RLC, and here I am getting a resistance. So make it open. So remove the load. So once I remove the load, what is the voltage coming here? I say this is V0. And this circuit also same, equal to this one. Remove the load. So you have V Thevenin, and then you have here R Thevenin. Okay. Now you have removed the load. Okay. So what is the voltage coming here? Now, what is the voltage across this terminal? First, tell me what is the current here? परमप्रीत, यहाँ से कितना करंट आ रहा है इसमें?
N upon R Thevenin.
ये तो ओपन है ना, करंट कहाँ से आएगा? Current, what is the value of current? 0.
0.
0. So that means whatever voltage here, there is no drop because circuit is open. So if you measure the voltage of is this terminal, it will come again equals to VThevenin.
Okay. Yes.
And here you measuring the voltage coming V naught. That is your VThevenin is equals to V open. VThevenin is equal to V open. So if I want to make equivalent circuit. Okay, so first I need to find the VThevenin, and VThevenin is nothing, that is the open circuit voltage. How much voltage is coming across the R, that is your open circuit voltage. So this way you can find the V open. Okay, next is I want to find R Thevenin. Okay, so if I want to make R Thevenin, what should I do? If all the sources present, if I make what? If I make this sources as a short circuited, if I deactivate the sources, okay, what is the resistance across this terminal? Tell me. What is the resistance across this terminal now? What is the value? What is the resistance between these two terminal? Radhika, what is the value of resistance across this terminal? That you cannot see here how much resistance is there. R Thevenin, na? So if you want to measure the R Thevenin, so what do you supposed to do in the original circuit? Okay, short circuit, measure the open circuit resistance, open circuit. Okay, open circuit resistance while all the sources are deactivated. Okay, make all the sources deactivated and measure the resistance across this open circuit. That will be your R Thevenin. Once you know the R Thevenin and VThevenin, you can make this equivalent circuit. Okay, now let me show this with the example. Okay. So you have been given a 32 volts, 4 ohm, 12 ohm, 2 ampere. This is your 1 ohm, and this is your RL. Okay. Now I want Thevenin equivalent of this circuit. Okay, that is VThevenin, R Thevenin across this R. Okay, so first of all, I need to calculate VThevenin. Now, what is the definition of VThevenin? Tell me. What is the definition of VThevenin?
Open circuit voltage.
Very good. Open circuit voltage. You need to find the open circuit voltage. Okay, so with calculation of VThevenin, that is first find open circuit V open. Find V open. So make it open. Yeah, just make it open. And find what is the voltage here. What is the voltage coming here now? Okay. Now you have two sources. Okay. You want to find out the voltage here. So here no current is coming. So the voltage of here will be equal to here. So you need to find the voltage here. Now at this point you want to find the voltage. This will be your V open. Okay. This V open is equals to this same V open. Now you use either superposition principle or you use dot analysis. Tell me what is this V open. Find out this V open. Use superposition principle and tell me what is V open. Okay, and that is one more thing. Here the source is there. this is open, this is equal to this one. Here no resistance, they are parallel. So basically V open is this one. This is the same V open. Basically you want to find the voltage now across 12 ohm due to this source and this source. That will be same like your V open. Are you getting this question? Because this circuit is open, so no current can go here. So I is 0 here. Okay, so voltage here will be same like voltage here, and this voltage is same like voltage here. So if you want to find the V open, find the voltage across 12 ohm, and you have two sources. Find out and tell me what is coming. So say V open, either you can apply directly nodal analysis or superposition principle. Let me apply superposition principle because we are learning that one. So you will one more practice. So V open will be your say V1 plus V2. V1 is due to 30 volt. Okay, so let me find first V1. If I want to find V1, okay, I have to make it this open. Okay, so now current is going here, here, here. This is open, so no current is coming here. So V1 will be what? V1 will be simply, this is 16, 32
Right.
upon 16 into 12. Okay, so how much coming? 24 volt, 24 volt. Second case, I want to measure V2 due to this current source. Current value is 2 ampere. 2 ampere. Okay, so I have to make this as a short circuit.
30 volt is coming.
Very good, 30 volts. So 2 ampere coming here. This 2 ampere current will go here, and that will divide equally. Okay, so V2 will be say current here, current here, resistance of this one. So total current 2, resistance of opposite branch, sum of resistance 16. This is the current and current. So this is current. Okay, I'm writing in 2 step because people will not understand. This is the I2, and so this is I1. Okay, so now you want V2. So V2 will be your how much? 12 multiply by this. So this is 1, this is 8, this is 1, this is 2. So 1 by 2. So 1 by 2 into 12, that is 6 volt. Okay, so your this is your 24 plus 6. This is coming out 30 volt. Okay, so I have calculated using superposition principle. If you want, you can find the same thing with a nodal analysis. Okay, so this is your 32 volts. Okay, now let me use the nodal analysis now. So if I want to use nodal analysis, okay, so say this current is I1, I2, I3. One current is already coming here, 2 ampere. So I say this is I1, this is I2. Okay, now I can write I1 plus I2 are outgoing, I3, which is 2 ampere, is incoming. So I1, if I want to write, I1 will be your V open minus 32 divided by 4 plus I2 V open minus 0 by 12, and I3's value is 2 equals to 0. Solve this one. So V open will be 3 V open minus 696. Okay, I'm taking 12 LCM, and this will be V open minus 24 equals to 0. Okay, so you have 4 V open, and then you have a this is 120. Okay, so your V open again comes out 30 volt. So you can use any technique. So for whatever techniques you learn, you apply there and you practice your method. Okay, you can use this mesh analysis also. So I will suggest only to practice this nodal analysis and superposition more. Mesh analysis भी important है. Mesh analysis हमको काम आएगा ट्रांजिस्टर के अंदर, पर वो आसान है, तो दैट विल बी यू कैन डू देयर itself. Okay, so the first thing is over. Now I have this VThevenin. Now I want to find RThevenin. Okay, RThevenin के लिए क्या करते हैं? परमप्रीत बताओ.
Sir, all is short.
All the circuit not short, deactivated. So deactivation का मतलब है voltage short circuited, and this is your open circuited. Okay, now you have to measure here the RThevenin resistance. You have to measure resistance here. That will be your RThevenin. Okay, so tell me what is the resistance RThevenin? So in order to measure resistance, what do? You assume here source is there. So current is going here. Current is going here. Suppose here source is there.
17.
Current is going here. These are in parallel. Okay. So these are parallel. So RThevenin will be 1 plus 4 parallel to 12. Okay, 1 plus 4 into 12, and that is 16. So this is 4, and this is 3. So this is coming 4 ohm. Okay. So whenever I'm telling you technique, whenever you want to find the resistance, you don't know which resistance is parallel or this is series. So you assume a battery at an open circuit. Okay, and now current is going here. So current going here, and the current getting divided here. So where current just divides, those branches will be parallel. Okay, so this will be parallel, and the combination of this will be series to this one. So I'm writing this 1 plus parallel. So this is coming 4 ohm. Okay, now what will the equivalent circuit? Equivalent circuit will be your VThevenin is your 30 volt,
and RThevenin series.
and RThevenin is 4. This is 4 ohm, and again you can put your RL again here, RL. So this is your equivalent circuit of this one. Okay.
आप जो पैरेलल की ट्रिक बताई ना, 4 और 12 जो पैरेलल है वो समझ में आया, लेकिन 1 ओम ये सीरीज में कैसे?
ये 4 और 12 पैरेलल है.
हाँ,
बना दो पैरेलल. तो कैसे करेंगे इसको? ये एक रेजिस्टेंस आ रहा है, या आर ये आ रहा है. ठीक है, फिर ये दो आपके पास पैरेलल है. ओके, दिस इज 4 and say 12. यही तो है सर्किट.
ओके.
अब ये इन दोनों का पैरेलल एक इसका सीरीज भी नहीं आ जाएगा. क्लियर
सर?
हाँ हाँ
सर, लोड करंट अगर जब निकालना है, अगर यही 30 वोल्ट VThevenin है और RThevenin आ गया, फिर लोड रेजिस्टेंस है, तो अगर लोड करंट होएगा तो ये 4 और R लोड वो सीरीज में आएंगे.
वो सीरीज में आएंगे,
और V/R वो इक्विवेलेंट हो जाएगा.
V प्लस R प्लस 4 कर देंगे, जो भी रेजिस्टेंस है यहाँ पर. ठीक है. So we'll meet tomorrow. We'll do some problem tomorrow also. Okay. Thank you. कोई क्वेश्चन है तो पूछ लो. If you have any question.